Welcome back. Today I'll be discussing about some consequences of the axioms. First, we'll talk about four, we'll mainly talk about four, four consequences of the axioms. First, if A is subset of B, then probability of A is greater or equal to probability of B. That's the first axiom. Consequences we'll talk about. Second is if A and B are two events which are not necessarily disjoint, then probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Thirdly, this is called union bound. It says that probability of A union B is less or equal to probability of A plus probability of B. And next one, the last one is we have three events which are not necessarily disjoint, and we say that probability of A union B union C is equal to probability of A plus probability of B intersection with A complement and probability of C intersection with A complement and B complement. So that's what we're going to talk about today. Let's focus our attention on the first consequence. A, if A is subset of B, then probability of A is less or equal to probability of B. So how do we going to prove this formally? So how are we going to prove this formally? So let's first step is to draw the diagram. Here we have set A and we have set B. Now we'll express set B as A and union of parts of B which are not parts of A. So it's going to be A complement C. A complement B intersection A complement C. A complement. We can see that these two pieces are disjoint. Therefore, we can apply additive axiom, which says that probability of B is equal to probability of A union intersection of B intersection A complement, which is equal to probability of A plus probability of B intersection A complement. We know that all probabilities are non-negative, which means non-negative, which means this expression here, all probabilities are non-negative, means this expression here is equal to or greater than probability of A. Now we have proved that if A is subset of B, then probability of A is smaller or equal to probability of B. Secondly, we'll focus our attention to second consequence of the axioms, that is, given that probability of given that A and B are disjoint, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So let's start how to prove this. First, we have our sample space. Here we have two sets which are not necessarily disjoint. We have A here. Okay. This is A, this is B. This is set A, this is set B. And there is some overlap between them. Now what we want to say is something about probability of A union B. To this, we have to look at the A union B set. We see that there are three pieces to this set. First piece is A that do not belong to B but to the B complement only, which is this. And we'll call this set A. Another piece is A intersection B, and we'll call this B. And thirdly and lastly, element B that do not belong to A but A complement. We will call this C. So A, B, and C are three probabilities of respective areas or respective sets. Now let's express the two sides of the equality in terms of A, B, and C. Before we do that, we know that A equal to A and B intersection is the probability of this. B is equal to probability of A intersection B, and C equal to probability of B intersection A complement. Now let's express two-sided equality in terms of little a, b, and c. Probability of A union B. We know A union B consists of three separate probabilities. A union B is actually the three separate probabilities, which is probability of A, probability of B, and probability of C by additive axiom. Secondly, we'll take right hand side, which is probability of A plus probability of B plus probability of A intersection B equal to, now we know probability of A is sum of A and B. So we can say that A is sum of A plus B and B is equal to sum of B plus C. In same way, A intersection B is minus B. We will cancel out B, which is equal to A plus B plus C. So we are left with A plus B plus C. So both sides of equations are equal. At this point, whatever we prove bring us to a unique consequence of this equality. That is, probability of A union B is equal to or less than probability A plus probability B. This is called union bound. This is useful when we want to argue that certain probability is smaller than something. Now moving on. Now moving on to last consequence, which says that probability of A union B union C is equal to probability of A plus probability of A complement intersection B and probability of C intersection A complement and B complement, given that A, B and C are not necessarily disjoint. So how do we prove this? Let's say we have sample space and we have our A, B and C. A, B and C. Now we have to say something about union of A, B and C and its probability. We'll express union of A, B, C into three pieces. First is A itself. First is A itself. Second piece is part of B, which is outside of A. Part of B which is outside of A, that is B intersection A complement. And lastly, we have part of C that doesn't belong to A and that doesn't belong to B. So these three things make up A union B union C. Since these three pieces are disjoint, we can say that probability of A union B union C is equal to probability of A union B union A intersection union C union A intersection union B intersection. This one we can say that by additive axiom it is equal to probability of A plus probability of second piece, which is B union A complement, excuse me, B intersection A complement, and probability of C complement A, C intersection A complement intersection B complement. And we have proved our axiom. Let me quickly summarize what we discussed today. We discussed about four axioms. One is, if A is smaller than B, then probability of A is less or equal to probability of B. Given A and B are disjoint, probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. And thirdly, as consequence of we have proved, probability of A union B is equal or less to probability of A plus probability of B. This is called union bound axiom. And lastly, given A, B, and C are disjoint, probability of A union B union C is equal to probability of A plus probability of B intersection A complement plus probability of C intersection A complement B complement. Thank you so much.